Welcome to the 10th MATLAB Arduino tutorial. This video will cover how to read and visualize real-time temperature data with a digital sensor. We will be using the Texas Instruments TMP 102, which is a low-power, 2-wire serial output digital temperature sensor that operates over a wide thermal range. As shown by the graph, the TMP 102 is specified for operation over a wide temperature range of -40 to 125 degrees Celsius. The temperature is accurate to within half a degree up to 85 degrees Celsius, and has a resolution of 0.0625 degrees Celsius. Here's the pinout. Connect the supply voltage and ground to the 3.3 volt and ground pins of the Arduino. Since it is an I2C device, connect SDA to pin A4 and SCL to pin 5, ground ADD 0. Let's look at how to interface this sensor with the Arduino. First, include the I2C library with this line. Initialize the variables mode, byte H, byte L, temp, and temp C. The setup serial communication code remains unchanged from the first tutorial, except for the addition of the initialization of the I2C library after the character handshake. Leave the address blank since the Arduino defaults as master. In the main loop, we use this code to return distance values when requested by MATLAB. Read the serial data into the variable mode, and implement a switch for case T. getTempSent is a function that returns the temperature readings in centigrade. Send the temperature over the serial port to the computer. After the loop, define the function getTempSent. First, request 2 bytes from the sensor. A note on this 7-bit address. 4 TMP 102 devices may share one I2C bus, and read operations are addressed 72 to 75, based on the ADD0 pin configuration. Since we have grounded it to logic 0, we use decimal 72, which is found by converting the hex number to binary and bit shifting right once. Read 2 bytes from the temperature register, as the TMP 102 stores conversions as 12-bit values. Positive temperatures are denoted by the most significant bit equal to 0. Bit shift the first byte 4 bits to the left to form the MSB. Bit shift the second byte 4 bits to the right to form the LSB, then logic OR the two to combine. Multiply by the resolution of the sensor to get the temperature in degrees Celsius. In the case of negative temperatures denoted by the MSB equal to 1, complement the absolute value binary number and add 1. Last, upload the sketch to the Arduino. After programming the Arduino, let's look at how to read and visualize real-time data in MATLAB. We'll need the setup serial function created in the first tutorial, the close serial function created in the second tutorial, and a modified version of the readACC function shown here called readTemp. The inputs are S, the serial communication structure created by setup serial, and mode, a variable that matches the character of the appropriate case in the Arduino switch statement. Send the character in mode over the serial port, then read the value returned in the correct format. Here's an overview for how to make 3D graphics visualizations in MATLAB using surfaces. First, initialize the plotting matrices or vectors used. Second, create an axis and adjust the view for 2D or 3D. Third, create surface objects to form different 3D shapes. Fourth, set the display properties of the surface and combine or parent the surface objects with the axes. Fifth, draw the object in the axes. And sixth, update the shape and color of the graphics object using sensor data. Put this all together in the tempgraph.m script to read temperature data and display a visualization. In the first cell, enter the COM port that the Arduino is mounted to, and subsequently run setup serial. The third cell programmatically creates a figure, adds start-stop plotting, and close serial buttons. Next, the fourth cell creates the graphics object used in the visualization. This example shows how to display temperature as an area graph that changes color. initialize a row vector to index the data, and a row vector of zeros for our data. The vector limits contains the minimum and maximum values we expect our data to lie and can be edited appropriately. Create axes and adjust the view for the XZ plane using these functions, setting axes limits to prevent auto-scaling. Use the surface function to create a 3D graphics object. X data and Y data specify the rectangular grid coordinates. Z data defines the surface above the grid and colors it according to C data. Here, a 2D area graph will be displayed in the XZ plane by setting Y equal to 0. Set the surface edges and face to fill with C data values, and the parent property with the axes handle created above. The term parent property is a relationship between objects, allowing the surface object we created to be contained within the axes. Finally, in the last cell we will update the graphics object with real-time sensor data. Since we are using the temperature sensor, set the variable mode to equal the character T. Create a while loop to repeatedly get temperature readings until the stop button is pressed. After every reading, drop the oldest value, shift the data, and insert the most recent reading at the end. Update the surface data and color by setting the Z data and C data properties. Running the script, here's the output. A hairdryer is used to rapidly heat the air surrounding the temperature sensor. As the TMP102 increases temperature, the area under the curve increases and the color warms accordingly. Next, a fan is used to slowly cool the TMP102 from a distance. The area under the curve decreases and the color also cools. Thermal paths run through package leads and the plastic case of the TMP102. Due to the lower thermal resistance of metal, the primary path is the leads of the IC, which are affected by the ambient air temperature. As this temperature is varied, Newton's law of cooling is illustrated. Adjusting the limits variable to a smaller range, small bursts of hot air are noticeable. The changing color is much more pronounced within this range. Note that the rectangular sections of the curve are the effects of quantization by the digital sensor. Thank you for watching. Please visit matlabarduino.org for more videos.